Okay, so first part, or like the whole section from A4 is about rational expressions. Rational expressions are when you have variables in the denominator. So first thing we're going to talk about is the domain, how you find the domain. Okay, and domain is your x's. So your domain is whatever makes the equation work. So your technical definition is a set of all real numbers for which the expression is defined. Okay, now most of the time every number will work. You do have some exceptions. So your exceptions is your denominator cannot equal 0. So like let's say you had the expression 1 over x plus 2. My domain would be all real numbers except, and then I figure out what makes my denominator 0. So I could set this equal to 0 and solve, or I could just think in my head all real numbers except negative 2, because negative 2 plus 2 would be 0. Okay, your other exceptions are you square roots have to be greater than or equal to 0. So let's say you're finding the domain of the square root of x plus 4. So I figure out what makes this 0, which would be negative 4, and my domain is all real numbers greater than or equal to whatever made this 0, which was negative 4. Other than those two issues, you shouldn't have anything else that deals with, that should not just make your domain all reals. So I'm going to list some examples. Okay, so for each one of these examples, all we're going to do is we're going to define the domain. So my only exceptions that I have to worry about are denominators, a variable denominator, or square roots. Number 1 doesn't have any of those. So my domain for this would just be all real numbers. Okay, number 2, there's no fractions and there are no square roots, but I have this special case over here. So it's all real numbers, but this tells me that x has to be greater than or equal to 0. So that means I have to put all real numbers, and then I have to follow that, which is greater than or equal to 0. Okay, number 3, I have a fraction. So my denominator can't be 0. So I need to figure out what makes this 0, which is 2. So my domain is all real numbers except 2. Okay, and then the last one's a square root. So square roots have to be greater than or equal to 0. You cannot take the square root of a negative. So negative 1 is what would make this 0. So my domain would be all real numbers greater than or equal to -1. Okay, so this should get you through the first part, which is domain. Second part, we're going to talk about just simplifying simple rational expressions. Okay, so first off, the definition of a rational expression. Okay, which I talked about at the beginning, we're going to talk about these. Okay, this is a fraction that has a variable, at least one variable in the denominator. Okay, so what we're going to do is we're just going to simplify some basic rational expressions. Okay, so what I would do is I look at my fraction. If you need to factor, you'd have to factor it first. There's nothing to factor on this. So then I look to see what can I cancel, what goes into them. Well, if I look at 15 and 10, 5 goes into both of those. So 5 goes into 15 3 times, into 10 twice. And then I use my rules of exponents to cancel out my variables. So I have 2 up here, 1 down there, and 2 minus 1 is 1. So that'd be x to the first. So I'd have 3x over 2. Okay, now the difference between number 5 and number 6, I have adding or subtracting going on. Anytime you have adding or subtracting, that means you're going to have to factor. So, and I have to find things that are the same on top and bottom. So like if I look at 4y minus 8y squared, it has a 4 and a y in common. So I'm going to factor that out, and I'm left with 1 minus 2y. Okay, in my denominator, they have a 5 in common, and I'm left with 2y minus 1. Okay, you're going to have some problems like this, where you have it where they're almost exactly the same, except for the signs are switched. Like I have a positive 1 here, a negative 1 here, a negative 2 and a positive 2. What you're going to need to do is you're going to need to factor out a negative, either in the top or the bottom. So let's say I do it in the top. I'm going to factor out a negative. That's going to change this to be negative 1 and that to be positive 2y. Okay, we're only going to do that if they're the exact opposites, because then now those are exactly the same and they're going to cancel each other out. So my answer would be negative 4y over 5. Okay, we're also going to have to factor out number 7. Let's do the numerator first. So the first thing I'm going to do is factor out the GCF. They all have an x in common. So I'm going to factor out the x. And then I'm left with a trinomial. So I'm going to factor this down further. Multiply to get 6. Add to get 5. Would be 2 and 3. So my x stays out there, and this factors in the x plus 2, x plus 3. Okay, then my denominator is x squared minus 4. That's a perfect square, so it's difference of squares. Square root of 4 is 2, so this would be x plus 2, x minus 2. Then I can look to see, okay, what's the same? Well, they both have an x plus 2, so I cancel those. So I have an x and an x plus 3 in the numerator, and I have an x minus 2 in the denominator. These x's cannot cancel because this x down here is attached to that negative 2. So if something's attached, it has to look exactly the same. Okay, number 8, since there's adding and subtracting, we're going to have to factor. So on the top, multiply to get 12, add to get negative 7, be negative 3 and negative 4. So that factors in a y minus 3, y minus 4. Okay, then in the denominator, multiply to get negative 18, add to get 3, will be 6 and negative 3. So this will be y plus 6, y minus 3. And then I look to see what I can cancel. So the y minus 3's are in common, so I cancel those out. And I'm left with y minus 4 over y plus 6. Okay, once again, you can't cancel anything else because this y is attached to that minus 4 and that y is attached to the 6. Okay, we're going to do one more of these. I just want to make sure you remember your cubes. This is a difference of cubes. Okay, that's not z minus 2, z minus 2, z minus 2. This one you have to use your formula, or the a minus b, a squared plus ab plus b squared. So the top, cube root of z cubed is z, cube root of 8 is 2. So this would be z minus 2 times z squared plus 2z plus 4. Okay, and then if I look at my denominator, I can see now that I can cancel something. So the z squared plus 2z plus 4 is the same on top and bottom. Those will cancel. And my answer is z minus 2. Now, not every single time will something cancel, but most of the time it will. So go back and make sure you factored everything correctly. If you factor everything correctly and it doesn't cancel, then you would just leave it in the factored form. Okay, I'm actually going to stop there. We will finish the rest of the notes when I come back on Friday.